Hello friends, in this video we are going to talk about the various issues that are faced by the medium access control protocol, that is MAC protocol. In this topic we are going to talk about the reliability issue, we are going to talk about the various collision detection and collision avoidance issue, then cognition avoidance and the limiting factors for high speed network parameters. So let's begin with the topic. MAC protocol is basically used to provide a successful communication between the network layer and the physical layer. Now, there are certain parameters which require to be considered as a serious issue in case of MAC operation. So, the first issue related to the MAC protocol is nothing but reliability. Now, as we are using a wireless medium as a medium of transmission, therefore the error occur in the transmission of the signal is more as compared to the error occurs in the transmission by using a wired media. Because when the signal is transmitted wirelessly, it will get affected by many parameters. It will get affected by many interference and noises from the surrounding. That will not happen in case of wired medium. In case of wired medium, the effect of surrounding is having less effect on the signal transmission, and therefore in case of wireless medium, the error rates are more as compared to the error rates in case of wired medium are less as compared to error rates in the wireless medium. The packet error rates of wireless medium are much more higher than the error rates in the wired medium. For example, if we consider TCP cognition control mechanism, in which a packet loss is errorless, or we can say it is having more error assumed to because of the cognition and cognition control mechanism. So this will ultimately decrease the transmission rate, and along with that it will reduces the network cognition. But in case of wireless network, the packet loss occurs at every moment of time, and it is also occurs because of the various factors like multipath fading, then interference, shadowing, distance between the transmitter and receiver. As the distance between the transmitter and receiver is get increased, the signal strength is get reduced, and as the signal strength is get reduced, the error provides, or we can say the error having more effect on the signal, and because of that the data can get hampered or data can get damaged. Also, the multipath fading results into the loss of data or loss of data packets in case of data transmission. Multipath fading is nothing but the mixing of transmitted signal along with the signal which is reflected back from the receiver. So when these signals get mixed with each other, then it results into the damage of data. Also, the interference because of the various environmental noise. If we are working on 2.4 gigahertz frequency band, which is an unlicensed frequency band, then along with the communication technique, the electronic equipment, for example cordless phone, then microwave oven, they also operates on the same frequency range. So they can also create the magnetron tube which is used in the microwave radiates at the same frequency range. Therefore it may possible that the radiated frequency or the radiated signal from microwave may get mixed with the transmitted signal and causes the packet loss or causes the data loss in the transmission. So the interference from the surrounding also affects to create error in case of wireless transmission. A common approach to reduce the packet loss rate experienced by the upper layer is to introduce the acknowledgement packet. So when the acknowledgement is get received by the transmitter, it will make sure that the data is get transmitted successfully and received by the receiver successfully without any error. So acknowledgement frame, or we can say the acknowledgement plays an important role in data transmission purpose, and with the help of acknowledgement it is possible to reduce the chances of error occurrence in the data. Now next issue related to the MAC layer, or we can say the medium access protocol, is nothing but the collision avoidance. To minimize the collision, wireless CSMA/CA MAC protocols use collision avoidance technique in conjunction with the carrier sense. Now the MAC layer uses CSMA method, that means carrier sense multiple access. The term carrier sense is used in order to make sure that whether the channel or the carrier or the medium is free for transmission or not. So every time whenever node wants to perform the transmission, it will check or it will listen to the carrier or it will listen to the medium or channel to make sure that whether it is free or it is busy with some other transmission. If it is free, then it the node performs the transmission, and if it is not free, then the node will wait for the random period of time. Then the node will wait for the random period of time and again performs the retransmission. The node performs the retransmission attempts multiple time and the waiting attempts multiple time, and therefore it is called as multiple access method. And that's why the complete term carrier sense multiple access comes into the picture. Now collision avoidance is possible because of the random waiting period time of the node. When the node feels or when the node listens that the network or the channel is busy, then it will wait for the random period of time. Because of the randomness of the time, it is possible for the node to avoid the collision with a data from other node. If that randomness is not provided, then the node will wait for the same interval of time every time. Then there will be a two possibility. Either it will not get a chance of the data transmission, or second thing, it will perform the data transmission and collision occurs. So because of that, the randomness is important in case of collision avoidance. The collision avoidance is implemented by making the node to wait for the random chosen duration before attempting to transmit the data after channel is sensed as an ideal. As we just discussed, the randomness of the time period is important for avoiding the collision in case of data transmission. Now next is the issue of MAC layer is nothing but cognition avoidance. When the node detects that the medium is ideal, it chooses back-off interval between 0 CW, and here CW is nothing but contention window. Now it is having two values, minimum and maximum value. So the minimum value is represented as CW minimum and maximum value is represented as CW maximum. Now here we can see the operation of the cognition avoidance. So let's understand it. Now in the diagram or in the figure, B0 and B1 represents the back-off interval of node 1 and node 2. Now we assume that the value of CW is nothing but 31. Node 1 and node 2 have chosen the back-off interval of 25 and 20 respectively. For node 1 it is 25 and node 2 the back-off interval is 20. Node 2 will reach 0 before 5 units of the time earlier than node 1. As back-off time of node 2 is 20 and back-off time of node 1 is 25, therefore it is possible for node 2 to reach 0 before 5 units of time earlier than node 1. Now when this happens, then node 1 will notice that the medium become busy and freeze its back-off interval currently at 5, because the node 2 is already reached over there, and because of that node 1 finds that the channel is busy and therefore it will freeze the back-off interval at 5 only. As soon as the medium becomes ideal again, the node 1 resume its backup countdown and transmits its data once the back-off interval reaches to 0. So in this way the collision avoidance can be, or we can say the cognition avoidance can be, takes place. Now there are many other issues also related to MAC along with reliability, collision avoidance and cognition control. So let's discuss the other issues which are related to the MAC layer, and they are fairness. First issue is fairness. Fairness has many meaning, and one of them is nothing but we can say that the every station should get the equal bandwidth. Unfairness will eventually occur when one node back off much more than some other node in the same neighborhood. So if the waiting time of one node is more than the waiting time of other node, then it's not possible that every node get an equal opportunity to use the medium properly or to use the or to share the received bandwidth equally. So that results into unfairness, and that is considered as one of the important issue in case of MAC layer. The MAC AW solution to this problem, which was implemented in 1994, is to append the contention window value to the packet a node transmit, so that all the nodes hearing that CW use it for their future transmission. So by using the value of CW, it is possible to avoid the problem of fairness and unfairness, and all the nodes present in the network get equal chance to use the medium properly and to share the bandwidth equally amongst them. Now CW is an indication of level of cognition in the vicinity of the specific receiver node. The MAC AW proposes maintaining a CW independently for each receiver. So for every receiver or for every node in the network, there is an independent value of CW is present, and because of that only it is possible to avoid the problem of fairness and unfairness in the MAC layer. In case of MAC layer, all the protocols are discussed. They are nothing but sender initiated protocols. So in other words, we can say that the sender always initiates the packet to transfer to the receiver. The receiver might take an active role in the process by assisting the transmitter in a certain issues such as collision, avoidance, and some part of the adequate rate control. So this is also considered as one of the issue in case of MAC layer protocol. Now, apart from these issues, there are certain factors which limits the high speed network performance, and the factors are, first of all, atmospheric scattering, then reflection, then refraction, or we can say diffraction of the signals. So all these issue causes the signal to arrive at the receiver with the delay, and therefore it will results into the intersymbol interference, that is stands for ISI. Now, but first of all, the limiting factor for speed is fading due to the multipath propagation, and the fading between transmitter and receiver is caused because of the factors like just we have discussed, that is atmospheric scattering, then it is because of the reflection, it is because of the refraction. Now here figure shows the multipath propagating or multipath propagation of the radio signal, where the signal is get scattered, that will result into the multipath fading. Then the signal is get reflected, and when the transmitted and the reflected signal get mixed with each other, then it results into the multipath fading. Also the signal is get diffracted. Only the few signals get received directly from the tower or from the transmitter to the receiver. The signals, when transmitted in all the direction, it get results into the loss of signal because of the scattering, because of the diffraction, and because of the reflection. So this is how the multipath propagation of the radio signal occurs. The next is nothing but the frequency selective fading. The frequency selective fading overcome by using a spread spectrum or by using the OFDM. The spread spectrum includes both spread spectrum, that is frequency of spread spectrum, as well as direct sequence spread spectrum. In spread spectrum, the signal is processed into occupy a considerable greater bandwidth to a less impact on the frequency selective fading. Then it is possible to reduce the effect of frequency selective fading. Now in case of OFDM, the data stream is split into certain number of substream, each having a bandwidth smaller than the coherent bandwidth of the channel. So by having such type of method, it is possible to reduce the selective or frequency selective fading. And in case of OFDM, which stands for orthogonal frequency division multiplexing, the channel, or we can say the stream, is get divided into a smaller part, and each smaller part having a bandwidth which is less than the coherent bandwidth of the channel. Now the Gaussian frequency shift key modulation, that is GFSK modulation, is a modulation type in which the data rates first filtered by the Gaussian filtered into a baseband and then modulated with the single frequency modulation. Now the another type of modulation technique is DBPSK, and it is basically a phase modulation technique which uses two distinct carrier phase for data signaling and provide 1 bit per symbol. The another type of modulation technique is nothing but DQPSK, and it is also a type of phase modulation. It also uses two pairs of distinct carrier phases in quadrature to signal to provides 2 bits per symbol. Now a third physical layer alternative not widely used, that is infrared system using near visible light in the range of 850 nanometer to 950 nanometer in the transmission medium. So by using this technique, it is possible to reduce the multiple frequency fading, or it is possible to reduce the frequency spreading in case of MAC layer. So this is what about the various issues that are faced by MAC layer, which includes reliability issue, which includes collision avoidance, then it includes cognition avoidance, and many other factors like fairness, that means equal distribution of the available bandwidth to all the nodes present on the network. So I hope you understand the topic of medium access control protocol issues. So thank you very much for watching this video. Stay tuned to Ekeeda, subscribe Ekeeda. Thank you.